So I haven't made a video in a while, but this is just gonna be calculus again. Um Sorry, I have to. It's 2.3. Um it's part of the famous early transcendentals book. I think it's by James Stewart. If you're following along, I don't think I've mentioned that before. So whenever I say 2.3 basic differentiation formulas, you'll know where to look in your textbook if you're following the same textbook. And I know a lot of people do because James Stewart made a fortune off his books. So let's go over the basic differentiation formulas, and I'll kind of explain a little bit about why each is the way it is. So the differentiation of any constant is just zero. Derivative of any constant is just zero. I mean, that's pretty self-explanatory. Constant doesn't affect the rate of change. Think of a line, this plus c term or the plus b term in the y equals mx plus b formula has no bearing on the rate of change. That would just be the slope. Next thing, power functions. The derivative of x is just 1. And we'll get to that a little bit using the power rule. But, I mean, that's pretty self-explanatory. Let's take the function y equals 1x plus b. Remember, the b doesn't matter because it's just a constant. So the derivative of x is just 1 because that's the rate of change. That's how fast any part of the function is moving using some simple logic. So yeah, and then getting through there, we get the power rule, which is the derivative of x to the n equals nx to the n minus 1. So if we do a practice question like d over dx of x squared equals 2x, because we just bring the 2 down right here and then subtract 1. So a harder one, I'm just going to make one up. 4x squared equals 8x. The derivative of 9x cubed is equal to 27x to the squared. C is just rapid fire. And remember the derivative rules. So the derivative of the sum of two functions are just going to be the derivative of each function. So yeah. Note that the power rule also works for negative powers. So let's take the derivative of 1 over x. Quite easy. Remember that this is just the same thing as x to the negative 1, because x to the negative 1 simply means that you're dividing by power of 1, because remember 1 divided by x is equal to x to the 0 divided by x to the 1, which is just x minus 1 using some exponent rules for some logic. And then you just apply the power rule. Pretty easy. And the reason why the power rule works is through something like the binomial expansion theorem. They proved it using some binomial expansion theorem. Again, as you mentioned, that's kind of like Pascal's triangle using the x plus h to whatever power. Because remember, the derivative formula is the limit as h approaches 0 of f of x plus h minus f of x over h. So that's just x plus h to the nth power minus x to the nth power over h, which they use the binomial expansion theorem for. So quite easy. But here it would just be negative 1 and then x and negative 2. So note that we don't decrease this in magnitude here. We just subtract the 1. So same logic here. Everything is the same. It's just negatives now. Now let's get to the equation of the tangent line through y equals x square root x. So using some logic, that's x to the 1 times x to the 0.5, which is the same as x to the power of 1.5. Apply the power rule, which also works for non-integers. So it's going to be x 0.5. And it says find the equation of tangent line at 1, 1. So the derivative at 1 would just be 1.5 x to the 0.5, which is equivalent to just 1.5. So the slope is 1.5x. So y equals 1.5 x plus c. And note that you could just plug this in to find the tangent line. So 1.5 plus c equals negative 1/2, meaning that y equals 3x over 2 minus 1 over 2. And you can simplify this even further. But if you would graph this, it would intersect the point at exactly 1, 1 and go straight through it with a slope of 1.5, meaning that the rate of change is 1.5 at that exact point. Simple logic here. Constant multiple rule. D over dx of c f of x is just f or c times the d derivative of f of x. That's quite simple actually. The reason being is, remember when we took the derivative of 3x squared? I used a shortcut. I just times it. Well, it's not really a shortcut. It's the same thing. I just times the 2 over and then subtracted it by 1. But they want you to pull it out, so it would be d dx of x squared. And that's because this doesn't create a rate of change, it just amplifies the rate of change. So yeah, simple logic there. Sum rule. Actually, we didn't cover this yet, it seems like, but as I explained before, f of x plus g of x is equal to derivative of both. So kind of like um, the distributive rule or distributive property. You're just distributing the derivative thing. And same thing with the difference quotient, or the difference, not the quotient, the difference, or the sum rule, difference rule, or sorry, yeah, the difference rule. Just same thing with the negative. So it would be f of x minus g of x equals the derivative of d of x minus the derivative of g of x. Quite simple. For the trigonometric ones, I did see the proof of it. It was some proof, but I don't remember it, so I'm not going to explain that here. The derivative of sine of x is cosine of x. Derivative of d of x of cosine of x is equal to sine of x. Whenever you find the derivative, you can just use some logic using the simple ones. Negative sine of x. And you can determine which is which derivative. So yeah, it's pretty simple here. And note that these are kind of like periodic. They repeat every fourth derivative. So that means the d fourth of d to the x to the fourth, I believe. No, it's d fourth to the x, actually. Should be the right thing. Of like sine x is just equal to sine x, which is quite interesting. Maybe there's some rule for that you can figure out. Actually, I'm sure they figured it out because there's often discussions about which derivatives equal the root function. So yeah, it's pretty easy. And yeah, that's pretty much it. There's an application here which is quite simple. Like if we take a kinematic equation like equals at squared plus bt, the rate of change is just going to be power, which is 2at plus b, because this is just the power of 1, so bring the 1 down and then subtract by 1. If it's power of 0 is just 1, so it's just b here. This is the rate of change. So that means whenever 2at plus b is less than 0, it has a negative slope, meaning that it's has a negative rate of change. Oh, that's a positive slope. It has a negative rate of change. But whenever it's above 0, it has a rate of change. So you can solve this for the intervals, which it is greater than 0. And therefore, that would be the intervals of increase and decrease, and will also be where the function has a positive slope. Same thing, when it equals 0, that means it doesn't have a rate of change. So that's pretty much it, calculus. So yeah.